On your next pages, you're going to practice applying properties of circles and triangles. So if we look at our challenge 1, we can see we have a right triangle with two legs of 30 meters and 16 meters. So to find the hypotenuse, which is the diameter of your circle, you can do the Pythagorean theorem. 30 squared plus 16 squared equals your diameter squared, right? The sum of the two legs squared equals the hypotenuse squared. So if we evaluate this and combine our like terms, we've got 1,156 equals that diameter squared. To undo that, you take the square root of each side. So the absolute value of D ends up being 34. So if the diameter is 34, the radius is half that amount, which would be 17. And again, to find the circumference, it's the diameter times pi. That would be 34 pi. For our slide 24, again, we have another right triangle with legs of 3, 4, and we're looking for the diameter. So substitute those into your Pythagorean theorem and evaluate. So our diameter here would be 5 units positive, right? Because we only have positive lengths. The radius would be half the amount of 5, which is 2.5 feet. And then the circumference would be the diameter of 5 times pi, so 5 pi feet. For your slide 25, notice how we have a square inscribed that's inside a circle. And the side of the square, or the leg of the right triangle, is 10. This is a special right triangle. We could use 45, 45, 90 to find the diameter. We could use Pythagorean theorem again to find the diameter as well. So we'll stick with Pythagorean theorem in case you forgot about your special triples. Evaluating that, again, we have a perfect square factor here of 100, so that would be 10 squared to 2. If you remember, your 45, 45, 90 says take the leg of the isosceles right triangle times the square root of 2, and that is your hypotenuse. So the radius would be half that amount, so that would be 5 squared to 2, and the circumference is the diameter length times pi, so we would say 10 pi square roots of 2 inches. For our challenge here, again, we have another right isosceles triangle inscribed in your circle. So again, you could do Pythagorean theorem, or you could have used your special triple, 45, 45, 90, to get the length of the diagonal. And again, for these, it's squaring each piece. So 4 times 4 is 16, square root of 2 squared is 2. That's how we got the 32s. Add them together again and simplify by taking the radical. The diameter is 8. The hypotenuse of that right triangle is 8. Also remember, you're taking the square root of 2 times a leg. Square root of 2 times square root of 2 is 2. And times 4 gives you back the 8 again if you did your special triple. So if the diameter is 8, the radius is half that amount, 4. And the circumference is the diameter times pi, which would be 8 pi centimeters. Your next one, here we have some right triangles within our circle here. We could look at triangle ADB or CDB, where we know one leg is 5, and they gave us the circumference of the circle being 26 pi. So if we start with the circumference, remember, the circumference comes from 2 radius times pi, or pi times diameter. We're going to undo it to find the radius, which would be AD or BC. Those are the hypotenuses for our triangle. So I would divide this by 2 pi, and that would leave me with a radius of 13. Now that radius, again, represents the hypotenuse of your right triangle, so we just have to find the missing segment length for BC, and that will help me get the length of my chord, AC. So again, we would just undo the Pythagorean theorem here, so square each of those amounts, do your subtraction, take your square root of each side, and we find out that the length of BC is going to be 12. Some of you might have recognized it was a 5, 12, 13 triangle, and you got that length pretty quickly doing that pattern there. Now BC is only half the chord length of AC, so if we double it, we'll get the length of AC, which would be 24 units.